of software. This software is a small tools that run on macOS or Windows, and these tools are meant to support, facilitate performance creators in working with generative approaches. So generative approaches in the sense of using algorithms for creative purposes, where the algorithms take some creative decisions on their own. And so these tools, they consist of both sort of conventional generative algorithms, like hand-coded algorithms, but also techniques that are based on machine learning or tools that have been trained on, for instance, dancers' own movements. The tools, they are meant to support people with a very wide range of technical skills, also both people who are proficient in programming, but also people who are not. And the tools should be fairly modest when it comes to the computational resources you need, the amount of training data you need. This is an important point. So you are able to train the machine learning part of the tools with very small data sets, which means data sets that you can collect of your own, that can consist purely of your own artistic work or not other people's artistic work. Then the second part is data sets. Data sets are recordings of dance rehearsals or dance performances in the form of video, audio, and mostly also motion capture, which means kinematic recordings. We have universal and signature-specific dance material covered with these recordings, where signature-specific means the choreographic material, fingerprint of Muriel Romero, choreographer at Instituto Stockholm, or also of Emilio Greco at ICK. And these data sets, they are available together with the software as kind of open source tools or the Creative Commons licenses. So you're invited to work with this material, create work out of this material, and you simply have to quote the origin of the material.
Okay. So the pilot has, let's say, these two main parts. One is the tools that we will present today with the demo, and now we will comment it in more detail, and the productions, or the productions we presented so far. So maybe Daniel, you want to mention?
Yeah, so the first part I will be very brief because this repeats afterwards. So we group the tools into several categories based on their main functionality. So there are tools for which we call motion utilities, that are tools that help working with motion capture data. Then the tools under the category of motion analysis. Can you go? Yeah. They are meant to analyze live or pre-recorded motion data, where analyzing means extracting higher level, potentially qualitative aspects of dance from dance recordings. Then the tools under the category movement synthesis, motion synthesis, deal with creating in an algorithmic manner synthetic forms of dance. Tools under motion sonification are meant to translate movement into music, and the tools under motion visualization should be the last one.
Yeah, there is a, sorry. There is a spelling mistake. It's visualization. Yeah.
So the motion visualization tools that translate movement into computer graphics, essentially.
Yes. And then below, what you see is a series of performances. Some of these performances, they are created by Instituto Stockholm, like, for example, Re-embodied Machine, which is, we will show some examples afterwards. This is a piece which the body is transformed into... What?
There's a webinar participant not muted.
Okay. Okay. Yeah, this is a performance in which one dancer uses the body expressivity to turn it into light, sound, to turn the stage into a dancer. Then Society 5.0 Festival is a small performance we did in collaboration with one of the partners, with AK, with a freestyle dancer from Amsterdam, Jason. Then AK ID Lab Open Dag, that was a series of performances that we did at ID Lab, like during the open days of the school. Sonification Battle is a sonification, like say, competition between flamenco and street dance that we did in the Madrid Open Days, Premier Open Days. Then is the prelude to ICK's Nulla Radeau, another of the partners. That's a big production at the Philharmonie de Paris. And the prelude of these performances, of this performance uses the AI Toolbox. Incubatio is a production by Instituto Stokos focused on an ancient ritual called Incubatio. And then Hashtag Incubatio is an extension of this performance by the National Ballet of Spain, Compañía Nacional de Danza. And then there is this Lilith installation, and maybe you can explain this too, Daniel, better.
Yeah, this is by Owen Desteban, two dance artists from the UK, and the installation sort of follows the narration of a girl who has been frozen because she was deadly ill, and they reincarnate the girl through AI by having the AI perform movements that are reminiscent of somebody discovering her body again. And it's a video installation, an LED cube with 4 sides, LED panels, and you can walk around and you have always this 360 point of view on this revived girl.
Okay. And
the last one I can also briefly mention. So we have been organizing several workshops, and some of these workshops, also these are called choreographic coding labs. That's a format that tries to invite and inspire artists working with technology, mainly creative coders, by concepts and techniques from contemporary dance. And these workshops, they last for 5 days, and the last day typically involves a small showing. So several of these showing presentations have been created also with the help of the AI Toolbox.
Yes, exactly. And as part of the AI Toolbox evaluation of the tools, we not only we did performances, we did a very large series of workshops with different collectives, different artists from disciplines, and even from with groups of elderly people that can use the tools also as part of their creative activities. Yeah. Yeah, so well, this is also connected to the pilot, the structure of the pilot, how it relates with the other premier pilots, no? And one of the most intricate connections is with the use case 2, is the 3D virtual theater, the live streaming of performances. And this is something you will have the opportunity to see if you come to Oporto the 18th of September after the webinar. Caterina will detail this event. So this what you see on the right is the pipeline of how the AI Toolbox, the dance creation environment, connects with these use cases. Maybe Daniel, you can explain.
I can mention briefly the principle of the pipeline. So the AI Toolbox consists, as I already said, of many small tools. And in order to create a performance piece or to translate the live performance into a VR experience, you will chain together some of these tools. And this chaining together is shown here. So all of these tools, they exchange data among each other. So what the arrows indicate. So from top to bottom, for instance, you have always a live performer. That's the black dancing figure, who is being motion captured in real time. This motion capture data is being analyzed for particular movement qualities. These movement qualities are then mapped, for instance, into the 3D virtual onto a 3D replica of the dancer as an avatar, and the live dancing dancer then animates the dancer on the 3D, on the virtual stage. So that's what the top pipeline shows. Then at the same time, the dancer who is live performing is controlling both on stage and in the 3D virtual theater music, live music, and also the light situation, both spotlights, robotic spotlights, and also laser light. And these bottom pipelines explain a little bit which combination of tools allows for this. So the dancer again is being motion captured, movement principles are extracted through motion analysis. These are then mapped on parameters for controlling the light, the robotic light, the movement pan and tilt, or controlling the shapes that are drawn by the laser light.
Okay. Yeah. Well,
Yeah, this is more or less the same. It's just in a more generic way that typically the first set of tools in such a pipeline deals with motion data, acquiring motion data, processing motion data. Then very often the second tools are dealing with analyzing the motion data. Or the motion data can also come not from a live performer, but from an algorithm. That would be the motion synthesis box here. So these type of motions are analyzed and then via parameter mapping used to control music, also typically sound synthesis, or computer graphics, or elements on stage, in particular light on stage. And there are different technologies the AI Toolbox uses for that. Well, first of all, we developed the AI Toolbox mainly for Windows and Mac OS. Linux should work, but is not tested. And then we make other uses of software tools or development environments, such as Super Collider for sound synthesis, PyTorch for machine learning, Python in general for most of the programming, apart from the Super Collider part, scikit-learn for machine learning. And OSC, Open Sound Communication, is sort of the kit between all these modules, because this is how these tools exchange information among each other.
Okay.
Yeah, this is an overview of the 5 categories again, with all the tools in each category, where the color coding more or less just means at which stage during the project these tools have been implemented or refined. So green are the newest versions of tools. So under motion utilities, you have tools for playing back motion capture data, for recording motion capture data, or if you're working with the commercial motion capture system, then tools for converting the native protocol that the motion capture system uses to OSC for sending the motion data to the other tools. Then in motion analysis, there are tools for extracting pose information, kind of do motion capture based on video recordings, live recordings, or pre-recorded recordings. There are tools for extracting movement descriptors, for conducting analysis on the movement. There are tools for classifying movement that you can train on your own classes, on your own movement principles. And then there are tools for reorganizing your movement based on some sort of similarities. And these similarities can be based on movement descriptors. Then motion synthesis. There are tools that are based on machine learning for working with existing motion capture recordings of dancers, transforming, blending these movements in between, or continuing movement based on a short start movement. So the model or the tool predicts how the movement will continue over time. Models, algorithms that have been trained on duet performances, and the tools predict how the second dancer would react based on what the real live dancer is currently doing. And then there is a set of tools that fall in the subcategory motion simulations. There are tools for working with non-human bodies, non-human type of movements, and that employ some sort of simulation for this purpose. Then maybe you say something for motion signification.
Yes, the motion sonification is translation of movement into sound, provides some models, synthetic models of simulating natural instruments, but that they expand to a wide palette of sound, starting from the physical models. And this is a simulation of the flow of the air through a tube, simulation of strings, of bowed strings, plucked strings, and simulation of synthetic voices. And this, the code of the motion sonification group has normally 2 parts. One is the synthetic instruments that can be used also to produce music, and also the mapping and, well, let's say, the orchestration of the movement principles or movement qualities, how we can orchestrate, like, what instruments, the information that comes from the body.
Okay, and in the movement visualization category, there are currently only 2 tools. One uses a technique called ray marching for rendering computer-generated images that represent an abstraction of the human body. And the other one is based on the very old technique, machine learning-based technique of visualizing activities of neural networks. And these neural networks, they operate on video images, live video images. And these can be video images coming from a stage recording.
Okay. Okay, so now we move to the demonstration. Okay, like demonstration, we will do two small demos, one from Dennis' computer, and then we will do another one from my computer and see also how the AI Toolbox connects with external softwares. Okay,
so I start. I will share my screen. So, okay, so what you're seeing here is the collection of tools according to this grouping I previously explained: motion analysis, motion simulation, motion utilities. These tools, this is what you get more or less when you download from an online repository these tools to your computer. So I start with, I show one tool per category only. So among motion utilities, an important tool is the motion capture player. So for each of these tools, there is a file that allows you to automatically start the tool by double-clicking it without having to type anything into a terminal. So what you will get when you do that is this type of window that plays as a stick figure a motion capture recording of a dancer, and that gives you a little bit of control which section you want to play back, how fast you want to play it back, and most importantly, this tool then sends data, meaning joint rotation, joint positions, via open sound communication to any other tool that needs them. So, for instance, as the second part, I can show you in the motion analysis category the motion mocap analysis. There are two versions of that, one in Python, one in C++. I'll show the Python version. Pablo will later on then show the C++ version. So these things take a second to get started. So, okay, here we go. So when I start this, so let's choose something to visualize. I started. And what you see now is this bar measures the distance that the dancer travels across stage, or the area that the dancer covers while moving on stage, or for instance, space effort is the direction. This is one of the Laban effort factors that is analyzed algorithmically, that in this instance tells you how direct or indirect the movements are of the dancer. So you have these kind of movement principles of movement categories to choose from, and by checking them with a checkbox, then this tool will send this information via C again to another tool. So that's the way that you would work when chaining together different tools. Then I jump to movement synthesis examples. For instance, motion continuation is a machine learning based tool that has been trained on motion capture recordings of a solo performer. In this case, it was Muriel improvising. And the tool has learned to anticipate how movement will continue over time. So most of these tools, they come together with a small graphical user interface, which I can show you here. That's this thing that allows you to specify the beginning of this input sequence that the model will then try to continue over time. And it also allows you to interfere with what the model is doing by overwriting some of the input sequence. For instance, here I'm modifying what the left shoulder is doing of the dancer. So that's one way of interacting with this tool that could be, for instance, done by a dancer who is live motion captures and control this artificial dancer. So this is one example. Then the other example I would like to show is one of the movement simulation tools. There are three of them. I show articulated bodies. This is the C++ thing. So what you see here is obviously non-anthropomorphic shapes that I have implemented behaviors for them that are reminiscent of some of the movement qualities that Muriel Romero works with. So I briefly show you what this thing is doing. First of all, let's get a better view. So there are, for instance, one movement quality is called thrusting. So I can make all this perform thrusting, like throwing your body part into space and let it rebound afterwards. Another movement quality Muriel calls fluidity. These are smooth movements on the arms, that would look like there is fluidity here, something like this. So very gradual, smooth movement. And there is a third one, which is not really a movement quality. It's a type of behavior that makes the arms move towards a particular location in space, which is indicated by this red ball. And this red ball could be a dancer on stage who moves around, and the arms would then follow it. And you can, of course, combine multiple behaviors on top of each other and have a combination of these. And as you will see later on in the performance excerpt, so these arms have their equivalent as robotic lights on stage, and they control the movement of the robotic lights. So the last thing I show before I give over to Pablo is a movement visualization example. For this example, I need to have the player again running. So this is a ray marching based movement visualization that takes the positions and rotations of the dancer's joints to create an abstract body image, body representation. So this is in the movement visualization, ray marching, this thing. Here we go, the window. And now I just have to see, yeah. So this, for instance, this is more or less an identical type of visualization where you can identify all the joints as simple geometrical primitives. And then if you choose other types of presets, also other kind of primitives, and the way you combine these primitives, these geometrical primitives, you can create very non-anthropomorphic looking shapes that sort of, yeah, the human body disappears while the movement sort of moves to the forefront, which is still then based on human movements. So that's from my side with the live demos. I stop sharing.
Muted. Okay, so very fast because I think we are
We are
not
running out of time.
very
Yes,
good
of course.
time-wise. Okay, so we will show now a different type of example, no? More connected to how we, for example, we use the AI toolbox in a performance, as Daniel explained in this overall view of all the tools. There are some tools that allow the let's say the OSC output, the open sound control connection between the AI toolbox and some other types of softwares. No? So I go again to these folders and I open the Xsense 2SC, which is a tool that we developed, Daniel has developed in order to connect with, yeah, hello? Okay, sorry.
Just continue.
Okay, that's something, okay. Yes, to use, for example, the information coming from the Xsense. Xsense is a software, also provides a hardware for motion capture. It's a company from the Netherlands that several partners have adopted, and also many artists and professionals from other disciplines, like from physiotherapy and so on. So what this piece of software does is to turn the movement that you see, 3D movement, into OSC data. Okay, so we can open another tool, the movement analysis tool, a different version that the one Daniel has shown. Okay, and we can use this tool to visualize the data, to extract data, for example, position, also Laban efforts, uh, like like the flow effort, etc. And we can use this information, we can stream it here, selecting all these principles in order to map them, for example, to sound, to visuals, or to anything. Okay, so let's see if it works. I don't know, probably there is a lot of delay. But this is one of the sonification models. It's a synthetic voice model. And as you see here, what we are listening is an orchestration of the 23 joints, the rotations, also the flow effort, the jerk, the changes of acceleration, the velocity, and some other aspects that are mapped to well, to several sonic parameters. Here in this interface, you can control the overall register, tessitura, and pitch. And you can listen the body in the register you want. You can also spatialize it and control the volume and also listen particular joints, like for example, just the right hand. You can listen both hands, all the joints again. And again, with the movement analysis tool, we can expand a number of qualities, principles. Okay. Okay, so I think now we move on to the next part of the webinar.
Yeah. Thank you. Thank you, Daniel. Thank you, Pablo. You are in time, 35 minutes. So now it is the time for Q&A.
It's possible to,
yeah.
sorry, to very briefly show some examples of the performances and also the GitLab?
Yes, sure.
Yes, but in 5 minutes, okay?
Yes, sure.
Okay. So this is the link, the GitLab link, where all
Can you
the
share the
tools are
screen?
there. Yeah. We can share the screen, or I can go directly.
Or you go directly to the GitLab.
Yeah, here. Okay. Is it there? Is it visible or?
You're not sharing the screen.
Okay. Let's see. Okay. Mm. Now?
Yep, perfect. Yep.
Okay. Yeah. Okay. So here are all the tools that you can download it and install. And most of the tools, they are very easy to install with a double click that runs a script. Okay. And okay, maybe I go back to the, let's see, because we are not within time. Okay, well. Okay, so now we'll show just some of the technologies in action. One of the productions created with the support of the AI Toolbox is a re-embodied machine. And this is a new feature that is coming. That is based on a swan simulation. Danny, maybe you can explain a bit.
Yeah, so this simulates the movement of bird-like entities, the coordinated movements, and we have been adapting this simulation so that it works with that dancers can interact with. So what you see here is red and black pyramids. These are two types of swarms. One swarm corresponds to the joints of the dancer, follows the joints of the dancers directly, and the black one is a second swarm that has a certain degree of autonomy that we can control live during the performance. So in this moment, this swarm just is attracted by different joints of the dancers. And later on, they become more independent of the dancer. And in turn, the swarm, the black ones, they control the position to which the robotic lights point to. So the dancer can, via this black swarm, control the movement of the robotic lights.
Exactly. And now you see how this behaves in the performance. See how the trajectories of the robotic lights, they are controlled by the swarms that are following the joints. And at some point, they can dance with the dancer. In this moment, they are very attached, very reactive. Now the dancer can, with a gesture, change the hand. So now the light will follow another hand, and so on. Okay, and yeah, this is with the same sonification model that I showed in the demo, how this can be combined with the movement of the light. So the rotations of the dancer control the rotations of the lights, and also each body joint is associated to a synthesizer. So it's what we call a multimodal interaction. Yeah. Well, this is one of the simulations, the synthetic movement simulation that Daniel showed. No, Daniel, the robotic arms. Yeah, and how this information is used to generate a light design in real time. So the the stage is transformed, let's say, into a dancer. Want to mention something, Danny? Maybe that the different qualities, how the different qualities of Muriel, they are assigned to the top top lights and
Yeah.
bottom lights. Yeah.
So Muriel sort of created a choreography for these arms, and the choreography consists of a sequence and contrasting qualities that are exhibited by the arms.
Okay. And so in the next example, if I get it to run,
Pablo,
yeah,
sorry. Could you please share the link for the shown resources? It is a comment in chat.
for them.
The GitLab.
Yeah.
Yes.
I
Yes.
can do that. You go ahead, Pablo, with presenting, and I copy it
Thank
into
you.
the chat.
Okay,
Thank you.
so this example is actually, we think is interesting to show because it's actually the same movement simulation, movement synthesis tool, these robotic arms, but it's visualized, you convey it, you make it tangible on the stage, not using robotic lights, trajectories or rotation, but with one of the visualizations produced with the Ray Martin visualization. So this is an excerpt from another production of Incubatio. And so you see this movement that is, let's say, incarnated, embodied by this creature, this like a spine, let's say. Yeah? And it moves into another projection screen under one of the Yeah, so this is Incubatio is one of the productions created with AI Toolbox, in which we use the AI Toolbox to support, let's say, the revival of a very ancient rite. The Incubatio is a very ancient practice that was employed by philosophers like Parmenides and Pythagoras in order to produce an image, what is called an archetypal images that are typical in dreams from people from many civilizations and from many epochs. You know, these are very old images that are like present across history. Yeah. Yeah. So yeah, this is the sonification tool. This is also used in a very particular manner to sonify what we call cataleptic movement. No, it is the movement is typical of trance states. So it was necessary to tune the mapping in order to map these very subtle and nuances of short of hypnotic movement, but it's a very natural movement that happens in everyday life. Like we are very focused, we are writing a letter, and suddenly we are very focused and we stop and we are kind of freezed, no, our body, because we focus our mental energy in the tasks we are doing. Right. And yeah, the last step is a multimodal interaction, a combination of the sonification and the visualization with the Ray March. Okay. Well, and finally, a last production that we did with the AI Toolbox is like a scale-up version of Incubatio with the National Ballet of Spain, with Compañía Nacional de Danza, in which we use motion analysis, motion sonification, visualization, motion synthesis, and interactive and generative live control. Okay, so I think now, sorry, we got a bit late.
No, it's okay, because there is a lot of material and interesting stuff to show. Yeah, thank you very much. Before we start our Q&A session, I just wanted to say that in September we will have the final event of Premiere, showcasing the tools that we were developed and the results of research. And also the performance by Instituto Stokos will be shown. Also, not only this performance, but also from ICK Theater from Amsterdam, dance company from Amsterdam, and the Academy of Arts in Amsterdam. And also you will be able to try to test all the tools that were developed during these 3 years of Premiere project. And also I would like to share with you the link to the Premiere web page, specifically on the page research, where you can find more information about all the tools that were developed during Premiere project process. So now it is the time for questions. And where is this final event? Here. The final event will be in Porto, in Coliseu Porto Ages. It's a big venue, concert venue, at 18th of September. We still didn't publish it on our web, but to know all the news, including this one, you can subscribe to our newsletter on the web that I shared, and you will receive notification when the registration will be open. So yeah, if you have other questions regarding iToolbox, please, you can share it, turn on the microphone or in chat, how you wish. Maybe who joined us a little later, you need some additional information, please don't hesitate to ask.
Well, maybe I can briefly add. So if you would like to try out the tools and download them and you stumble over problems, which is very likely, then don't hesitate to contact us. We are super happy to assist you.
To contact, maybe you can leave also your email.
Yeah, I do that.
Also, the GitLab is in a state of development. It's until the end of the project.
Yeah.
Yeah, I have a question if nobody has a question, if that's okay. I couldn't find the raise the hand button.
Yeah, please, Susan.
Yeah, thank you very much for the presentation. It's very nice to keep seeing how more concrete it gets every time you present it, and transmittable and accessible and very clear, and still learning to understand the terminology, the function, but slowly. I just, just out of curiosity, or like, what would be your next steps? Or it seems already quite complete. Or when you say it's in development, what are your ambitions, or where do you see still potential to expand on it in terms of research development, or what are your curiosities? Just for the sake of research development, let's say.
Yeah, maybe we can combine our answers. I mean, there are some things I hope to finish before Premiere ends, but maybe it takes longer. So these are the short-term goals. One of them is to bring more elements from our performances to the AI Toolbox. What is currently missing, the main thing that is missing is light control. So I'm working on some tools that allow you to control robotic light through movement. Have the light follow your movement or mirror your movement, things like this. So this is something that we want to add. There is another thing I would like to add is also concerning the translation of movement to music, that we have a machine learning model for this part. At the moment, the focus is on sound synthesis. So Pablo implements algorithms for creating sounds, synthetic sounds. And we would like to complement that approach with a model that the dancer can train on her movement, his movement, in combination with sound. And the model learns the relationship between movement and sound, so that when it's trained, the dancer can use it to sonify her or his own movement. So this is something that has been ongoing since the beginning of the project, and I still hope we have it done before the end. And the last thing I would like to add is that I would like to explore more the possibilities of interacting, especially with the machine learning-based models. So at the moment, these models in principle can be interacted with. They run in real time. You can change parameters, but it's not so obvious how to interact in a gestural manner through full body interaction. So this is something I would like to continue in this direction.
Yes, and globally, I mean, so we are optimizing the accessibility of the AI toolbox, how easy it is to install, and the tools, and also probably add some tools like, for example, Daniel commented the light, this light interaction that we showed, for example, in the body machine. This is not yet in the AI toolbox, but it's coming. And also how the interfaces and the models are easy to install across platforms, for example, for the sonification part in Windows, and well, this type of things. And also some new models, some new sonification models. Yeah.
Yes, thank you, Pablo. Thank you, Daniel. Maybe some new questions arised. You can answer them through chat or turn on the mic. And I again share with you in chat the link on our Premiere survey. If you didn't participate in it before, I encourage you to do it. Yeah. And if you have some questions, please, you're welcome. No questions. There were a lot of information and everything was super clear. Yeah, and really inspiring. So yeah, at least you can write us in chat if the webinar was useful for you, how you find it, if everything were clear. It will be very important for us to know. So if there are no questions, the proposal is to finish it. Thank you very much for your time, for participation, for really useful information, and hope to see everyone in September in Porto and Premiere final event. Thank you.
Thank you.
Thank you.
Bye.